Welcome back to Mark Carney's book club. Today I'm going to be starting chapter 11. So this chapter as well as the next chapter are both quite long, so I may have to start posting more than one video per day if I want to get this all posted by the election, which I am determined to do. Let's get into it. There has been 11,000 years of extraordinary climate stability since the last ice age, an era called the Holocene. We have created a new era, the Anthropocene, where Earth's climate is driven by our impacts on the planet as opposed to the geological rhythms of nature. So our climate has been changing since the Industrial Revolution. Since 1850, global temperatures have risen by about 0.07 degrees Celsius per decade. And in the last 3 decades, this pace has tripled. The changes since the Industrial Revolution have caused oceans to become 30% more acidic. Sea levels have risen 20 centimeters, and the pace of ice loss in the Arctic have tripled in the last decade. Extreme events, hurricanes, wildfires, and flooding are multiplying. There have been 5 mass extinctions in the history of our planet. Now, human activity is driving the planet towards the 6th at an unprecedented rate. Current extinction rates are around 100 times higher than average over the past several million years. Since I was born, there has been a 70% decline in the population of mammals, birds, fish, reptiles, and amphibians. These environmental losses haven't traditionally been valued, but now the effects of climate change are starting to impact assets with market prices, which makes the looming calamity more tangible to some. First cause he's going to go through is emissions. The UN's Intergovernmental Panel on Climate Change, the IPCC, has concluded that our current warming trend has unequivocally been caused by human activity. Rapid industrialization and global growth have increased the level of greenhouse gases, or GHG, particularly carbon dioxide, CO2, in the atmosphere at an alarming rate. It took 250 years to burn the first 500 billion tons of carbon. On current trends, the next 500 billion will be released into our atmosphere in less than 40 years. Scientists have looked at carbon emissions and temperature over the past century and have concluded that the pace of global warming is roughly proportional to the amount of carbon dioxide and other greenhouse gases in the atmosphere. Knowing these calculations, we can estimate our carbon budget, which is how much carbon dioxide can still be released into the atmosphere before we exceed different temperature thresholds. Limiting temperature increases to 1.5 degrees Celsius from pre-industrial levels keeps the Earth's natural systems from tipping into a dangerous feedback loop. The Earth has a number of feedback loops and tipping points, which could turn from virtuous to vicious and accelerate the process. For example, the polar ice sheets reflect light and reduce warming. As they melt, this effect is lost, making disappearing polar ice both a consequence and cause of a climate catastrophe. Similarly, the permafrost that underpins the land where I was born is now melting, setting in train a process that releases CO2 and methane, accelerating global warming. The prospect of these feedback loops is becoming more likely as the Arctic has warmed by twice the global mean. And they are not trivial. The IPCC estimates that carbon emissions from thawing permafrost by 2100 could represent as much as 1/3 of the 1.5 degrees Celsius carbon budget. To stabilize temperature rises to any particular temperature, we must reach net zero, which is the balance where the carbon emitted and taken out of the atmosphere is equal. He says net zero isn't a slogan, it's an imperative of climate physics. To get on the path to stabilize temperatures at 1.5 degrees Celsius, emissions need to fall by a minimum of 8% year on year over the next 2 decades. To put that into context, total CO2 emissions for 2020, which incorporated full-scale COVID-19 induced shutdowns of our economies, decreased by around 7%. To be clear, even at this crisis-reduced rate, we are continuing to spend our carbon budget, and we are not on track to meet our temperature goals. To limit temperature increases to 1.5 degrees Celsius, the average global citizen born today will have a personal carbon emissions budget over their lifetime equivalent to 1/8 of that of their grandparents. Think of that next time you hear, okay, boomer. And I think he's talking to the boomers there. I love it. He says this reduction of emissions demands wholesale structural change. The biggest contributors of emissions and those with the furthest to go to get to net zero are industrial processes, which represent 32% of our current emissions, buildings, which is 18% of our current emissions, transportation, 16%, and energy generation, 11%. This is the production and supply of energy, not its end use. And then food and agriculture represent 10%. Anywhere between 15 and 40% of the total greenhouse gases generated by petrol, diesel, and other transport fuels are generated before they even emerge from the refinery. Wholesale changes of our energy systems will be required to achieve net zero. This means converting the bulk of energy use to electricity and converting all electricity to renewables. Other technologies which could have decisive roles include hydrogen, particularly for heavy transportation, like trucking, shipping, and air travel, and carbon capture and sequestration, although they have a ways to go to become economic. So he talks about how some sectors are harder to decarbonize than others, such as aviation, shipping, long distance haulage, and cement and steel production. In aviation and shipping, biofuels and potential for hydrogen-powered engines could significantly reduce emissions. 3D printers can produce entire homes in 48 hours, reducing construction waste by 1/3 and emissions by half. That was the first thing in this book that I actually fact-checked. So I did look that up, and it is true. They're small for the most part, but nevertheless, yes, that is a true statement. So pretty cool. He mentions Bill Gates' book called How to Solve the Climate Crisis, which I didn't know was a thing. And it now makes sense how much money has been spent to villainize Bill Gates because he's going after big oil. So while various countries have more or less work to do, there is a global problem that needs ambitious collective action. Advanced economies had benefited from decades of unregulated emissions, industrializing at pace and growing their economies accordingly. But climate imperatives now require that developing and emerging economies do not follow their lead. It is the global analog to the need to shift greenhouse gas consumption from the voracious boomers to the sustainable millennials. Historically, the US has emitted about 400 billion tons of emissions, a quarter of all global emissions since the 1750s. Europe has emitted just over a fifth. Until 1882, the UK accounted for half the world's cumulative emissions, only to be overtaken by Europe, which was in turn leapfrogged by the US in 1950. In this historical context, Chinese emissions look relatively small, even though today China emits the most carbon into the atmosphere. The intensity of the emissions by Asian countries simply reflects the West's appetite for emissions, as we are net importers of emissions. So I'm going to wrap up part 1 there. Likely part 2 will be posted shortly after this one because I'm going to have to increase the frequency of posting if we're going to get through these all. So follow along for more.